Okay, I am back and live for day 5 of Advent of Cyber on TryHackMe.com. I've been slacking a little bit, having to do a lot of other things in my life, so hoping to catch up. We should be on day 7 or 8, I believe, by now. And let's jump right into it. Last one I stopped on IDOR, which is authentication bypass vulnerability, and we stopped at the co-author's note on this one. I have started the machines here, and let's continue on reading and see what's going on here. Identity defines our reach. To understand the root cause of IDOR, it is important to understand the basic principles of authentication and authorization. Authentication is the process by which you verify who you are. For example, supplying your username and password. Authorization, process by which the web application verifies your permissions. So, do you have permissions to access that resource or object or whatnot? Are you allowed to visit the admin page of the web application? Are you allowed to make a payment using a specific account? You may think that authentication can only happens once when you supply your username and password, but it is actually not the case. After providing your credentials, you receive a cookie or a token called the session information. Every subsequent request you make to the application includes this session information, which is verified by the application. This initial verification process is still authentication and happens for each request. This is why websites will often redirect you back to the login page. It means your session information has expired, and thus you need to re-authenticate with your credentials to receive new session information. Okay, so it's stored via cookie or a token, the whole session thing. Okay. Authorization cannot happen before authentication. If the application doesn't know who you are, it cannot verify what permissions your user has. This is very important to remember if your IDOR doesn't require you to authenticate, log in, or provide session information. Such as in our package tracking example, we will have to fix authentication first before we can fix authorization issue of making sure that users can only get information about packages they own. The last bit of theory to cover is privilege escalation types. Vertical privilege escalation, this refers to the privilege escalation where you gain access to more features. For example, you may be a normal user on the application, but you can perform actions that should be restricted for an admin. Horizontal privilege escalation, this refers to privilege escalation where you use a feature you are authorized to use, but gain access to data that you are not allowed to access. Okay. For example, you should only be able to see your accounts and not someone else's accounts. Okay. IDOR is usually a form of horizontal privilege escalation. You're allowed to make use of the track package functionality, but you should be restricted to only performing that actions for yourself, not others. Now that we understand theory, let's look at how to exploit IDOR practically. Iterate, digits, observe responses. Let's start with a simple example of IDOR. On the web application, let's authenticate to the application using the details below. Okay. Okay. I swear my copy paste worked at one point and now it doesn't. Look at that, I didn't even save it in the clipboard. Nope. Okay, not getting in here. Let's try one more time. Oh, because of the username. There we go. Okay. So once we log in, we should see the dashboard, which we do. Let's see here. Account information, my children, my vouchers. Okay. Let's start by using the developer tools of our browser to better understand what is happening in the background. Right click on the page and click inspect. Okay. Then click on the network tab as shown below. Perform a request or reload the page to see the detailed information about the network activity. Okay. Now let's refresh the page. Okay, let's refresh. And see what requests are being made. It should look something like this. Get. IP address. Okay. So we're receiving all of this information. Okay, let's take a look at the view account info request. View account. Click on it and you will see the following. What are we gonna see? Okay, we're gonna see the user ID equals 10. Oh, I see it. So this is the actual GET request right here. Even though we logged in with our credentials, doesn't show up anything up here. We see right here the user ID is 10, so we could probably copy this whole thing and change it to another user ID, right? Okay, in the developer tools, navigate to the storage tab. Storage tab. And expand the local storage. Okay. Let's change the user ID to 11. Okay. So will it be here? Because this is the authenticated user. Okay. And this is authenticated token. Okay. Okay, if you refresh. Oh, we're test@test.com. Yeah, we're a different user. That's insane. Let's try another one. It's another test, looks like. This is the simplest form of IDOR. Simply changing the user ID to something else means that we can see other users' data. Some IDORs might be slightly more hidden. Just because you don't see a direct number doesn't mean it doesn't exist. Let's dive deeper. To continue on to the next challenge of the task, go and change the ID back to 10 using the same steps you followed. Okay. Alternatively, you can log out of the application and log back in using this username and password. In disguise, obvious reference. Sometimes IDOR may not be as simple as just a number. In certain cases, encoding may have been used. On the loadout profile, click the eye icon next to the first child as shown in the image below. Eye icon, okay. Okay. Now go back to the network tab and take a look at the requests being made. You should see a request like this. Okay. Yep, I see request mg equals. And if we open this, more like this. Yep, I see the file name. Simply put the mg equals. Simply put, the mg equals is just the base 64 encoded version of the number 2. You could still perform IDOR using this request, but you will have to base 64 encode the number first. Interesting. Encoding isn't the only thing that can be used to hide potential IDOR vulnerabilities. Sometimes the values may look like hash, such as MD5 or SHA-1. If you want to see what that would look like, take a look at the request that happens when you click on the edit icon next to the child. Okay, and then we look at like this one. Close. We'll do the edit. Okay, then we got this one. So yep, that looks like a hash thing. MD5. If we understand what value was used to generate the hash, we can perform an IDOR attack by simply replicating the hashing function. using something like hash identifier. Huh. I wonder if we can do that. I missed a C at the beginning. Possible identifications. Possible algorithm. Oh, okay, just tells you what algorithm was used. Oh, okay, that's all it is. That I would do something else. It's deterministic, obviously reproducible. Sometimes you have to dig quite deep for IDOR. Sometimes IDOR is not as clear. Sometimes the IDOR stems from the actual algorithm being used. In the last case, let's take a look at our vouchers. While the values may look random, we need to investigate what algorithm was used to generate them. Their format looks like UUID, so let's use the website such as UUID decoder to try to understand what UUID format was used. Copy one of the vouchers to the website for decoding, and you should see something like this. And what is this? Okay. Let's take a look at our vouchers. So if we go here, yep. Standard string format, single integer value, variant. I'm not familiar with UUIDs. Contents, clock, notes. So there's the version and variants. Interesting. Contents. Interesting. While these look completely random, we can see the UUID version 1 was used. The issue with UUID 1 is, let's say version 1, yep, is that if we know the exact date when the code was generated, we can recover the UUID. For example, suppose we knew the elves always generate vouchers between 20 and 21, in that case, or 8 to 9. We can create UUIDs for that entire time period. 3600 UUIDs since we have 60 minutes. Oh, 1 per minute. And 60 seconds in a minute. Oh, per second, I mean. Which we could use in a brute force attack to aim to recover a valid voucher and get more gifts. Interesting. So let me see. So this one, okay, let's see the voucher right here. The time, contents time, it's like this. I'm gonna forget. This is random 5080. Did I do the same one? Let's just do this one. Okay, this time looks the same. Okay, but this changed. Maybe it's just not the way it's supposed to be. Now that we learn about what IDOR is, let's discuss how to fix it. The best way to stop IDOR is to make sure the server checks who is asking for the data every time. It's not enough to hide or change the ID number. Make sure the server checks who is asking. Okay. The system must confirm that the logged in user is authorized to see or change the information. Don't rely on tricks like base64 or hashing the IDs. Those can still be guessed or decoded. Instead, keep all the real permission checks on the server. Whenever a request comes in, check, does this user own or have permission to view this item? Use random or hard to guess IDs for public links, but remember, random IDs alone don't make your app safe. Always test your app by trying to open another user's data, making sure it's blocked. Finally, record the monitor failed access attempts. Record any monitor failed access attempts that can be early signs of someone trying to exploit an IDOR. Okay. Exploring the IDOR found in the view accounts parameter. What is the user ID of the parent that has 10 children? User ID parameter. What is the user ID? It's 10. Okay. Why am I confused on this one? Oh, are we going to the network, view accounts? What's the user ID? User ID is 10. What is the user ID of the parent that has 10 children? Oh, I gotta keep going through until I find somebody with 10 children, I guess. Okay. Nothing. Okay, I don't think this is it. Is a test. 13. No. Bunny, bad bunny. No children. Pickle has 2 children. All right, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alrighty, the user ID is, we said 14, 15. 15. Yay. Bonus task. If you want to dive even deeper, use either the base64 or MD5 child endpoint and try to find the ID number of the child born 2019. Let me delete this. Where does it tell me when they're born? Okay. I see 2015, 2019 for... So I could like view them. Okay, burps intruder. I don't have that. Haven't used it. This might be a little bit more advanced as far as it might be like a lot of children in here that might go into hundreds. I'm not sure. Let me refresh the page. And then, okay, when we click like here, we get this. Okay. Yeah, but how do I... Wait, the question is... Oh, that's what it is. I'm looking for this. Oh no, this is not it. I'm still here. If you want to dive even deeper, use either the base64 or MD5 child endpoint and try to find the ID number of the child born. How would I find like another, you know, hash for another child? What is burps intruder? Okay, so it's probably just one of those things where it's gonna be a bunch of stuff. It's not gonna be as easy, I don't think, without using the tool. Bonus task. You want to go even further, use parents, vouchers, claim endpoint. I don't understand what do they mean by the endpoint. API child. Like, okay, this is the root. API parents, parent vouchers claim. So here's vouchers. Do we go? Yeah, I'm not sure how to do these. Okay, so we got unauthorized on this one. But we could probably go to the Storage, local storage. Oh. Yeah, I don't need the API, right? Parents, vouchers. So right now it's user 15. We need a voucher that is valid on November 20th, 2025. It was generated exactly on the minute, somewhere between 8 and 12 UTC that day. Okay, which one did I copy? Did I copy the last one? 2025. We're looking for 20 November. These are all the same time though. Yeah. So these. Okay, this is different. 10-8. 10-8. We already did this one. This is 10-7. Oh man, 10-7. 10-7. 10-8. Okay, so it's another voucher that's not in here, and I'm supposed to find it somehow. Oh, we're just gonna give me the answer. What is this?
Hey everyone, of the that or get access, because it will make things to make a lot of requests with different IDs until I get the right. Yeah, burp is selected. Let me just which is burp suite. So just go do that 3,000 times. That wouldn't be fun. So let me check that. Perfect. Now I always like to click here on the hint button, so this orange light bulb here on the right, because now that we know the answer, I'm just curious to see what would be TryHackMe's approach to solve this question. So you can see here on the bottom left, using the task example, change the ID value of your token and refresh the page. Work in increment steps from your user's ID. Okay, so we did exactly that, so that's nice. But again, we were lucky that the answer was actually user 15, because if it was like user 3000, we would have to do that 3,000 times. That wouldn't be fun. So there are ways to automate that, and I think we will take a look into how to do that approach in just a second, because now we have two bonus tasks, and you don't need to do this because, as you can see here, there's no answer needed. Okay, there's nothing you need to provide on the answer. You can just click on the check button for both of them and you're good to go. But because TryHackMe know about all of you advanced hackers out there that want a little bit of a challenge, we have some extra questions for you. But I think it's still fun for everyone, especially if you're up for a challenge to just stay here and follow up and see how to find the answer for these little bit more challenging questions. So yeah, let's start with the first one. I'm gonna make this bigger again. So bonus task, if you want to dive even deeper, use either base64 or MD5 child endpoint and try to find the ID number of the child born on the 17th of April 2019. I hope this is the right date format. I think it is. To make the iteration faster, consider using something like burp's intruder. If you want to check the answer, click the hint on the question. Okay, cool. So this is what we are going to do. Let me go back to our attack box, right? And let's fire up the tool that we are going to be using, which is Burp Suite. So just go with your mouse to the right side, it will open the toolbar, and Burp Suite is this little blue square here on the right. Burp Suite is basically a proxy that you can use to intercept.
Wait, why do I not see it? So here. So this one. Yes, it is. Oh, it gave us a completely new window. Is there a way to put it back? No, there it is.
Accept your web requests from your browser before they reach the web server or the web application. So it makes things a lot easier to change a couple stuff on those requests and even to automate some stuff. So that is a very oversimplified explanation of what Burp Suite is all about. So here I'm just going to minimize the browser just to make things a little bit more readable for you. So here, yeah, just click here on next to do a temporary project and just use Burp default. This is going to load. And if you wanna, if you're curious about the setup, how this actually works, TryHackMe did a great job just having everything ready for you. Because if I open the browser again, and I'm going to move my head out of the way, take a look here on the, oh, sorry, that's Burp Suite wanting to be the protagonist and getting all the spotlight. Just wait a second. So if I go here and I point it to above my head, what is it? Yeah, there we go, right there. You see this little fox here on your browser? This is called Foxy Proxy. So it's basically an extension on your browser where you can use Burp as the proxy to intercept the web requests. So if I just click on Burp, things will work out of the bat. Now, if you're curious and you really want to understand how this works under the hood, just click on Options. You will see that there are a couple options here. If you click on proxies, you will see that there is already one created for you called Burp that is using the local IP address and the port 8080. If you go back to Burp, you select proxy on the top left, proxy settings here in the middle, you will see it's using the same exact IP, the local IP address, and the same exact port 8080. So that's how the traffic is being intercepted. Created for you called Burp that is using the local IP address and the port 8080. If you go back to Burp, you select proxy on the top left, proxy settings here in the middle, you will see it's using the same exact IP, the local IP address, and the same exact port 8080. So that's how the traffic is being intercepted. Enough about the setup. I know TryHackMe made this very, very easy, but still people might be confused, like, how is this working? Like, how in the world are we able to intercept these things? So that's basically the setup behind it. Let me put my face back up there. And right now, you can see here on the left, there's intercept on.
What tab is he on? Is he on? Oh, I just have this open, the settings.
So whatever I do on my browser, it will be intercepted right here. Let's test it. Let me open Firefox again, close this, and let me just, let me see if this is selected. Yeah, Burp is selected. Let me just refresh this page. There you go. You can see here on the right side, if I move my head, Burp has now been activated. You can see now on top of the browser extension, it says burp in green. The browser is loading, but nothing is happening. It's not really getting a response from the web server. Why is that? Well, that is because the burp suite.
Oh, why is it opening a new one? I thought I minimized. Oh, there it is. That's why.
Proxy is intercepting it. So if I just click on the intercept on button, it just turns the intercept off. And if I go into the HTTP history, you can click it right away, right there. You can see all the requests in here, which is pretty cool. So right now, everything I do on my main app, sorry, if I go back here, anything I do here, it will be logged on my burp suite. If you want to be even more professional, by the way, you can go here in the target blade on the top left, right click on the IP address.
Why am I sitemap? Let me go back a little bit. So what was he clicking on? He went to proxy and he went to HTTP history. So I have that. So now that he is
Burp suite proxy is intercepting it. So if I just click on the intercept on button, it just basically burp is going to ignore everything that is not part.
target scope. But why don't I have the sitemap? Settings burp browser allow. Okay. Okay, whatever. Let's move on.
Your scope, which in this case is our try present me application. So let's just click yes, because it will make things a lot
Now what the heck?
more cleaner and remove all of the noise from here from your history. So yeah, we know that we have to use a specific type of request, right? So we have to use either the base64 or MD5 child endpoint. So let's see if we have any requests that capture that. So for that, I need to go back to my web application and let's get some information about this kid. So for example, this kid right here, let's see what we got on our, yes, we got some requests in here. So number 4 is
Yep, right here.
nice, because I want to use the base64 one. I don't want to use the MD5. I think the base64 is easier to understand and it's a lot more cleaner. So right now, what I will do is I'm going to use a tool within burp that is called intruder. So you can just right click on this request, send it to intruder. And here inside intruder, you will see basically the web request that we are making. Now, we need to define the input to where we are going to run our payload. I know this sounds very complex, but what that means is that this MTE equals, we already know that this is a base64 number, right? So if I just copy this and I go back to CyberChef and
I'll just do it here.
instead of making it
to base 64. What am I doing wrong?
Now, we need to define the input to where we are going to run our payload. I know this sounds very complex, but what that means is that this MTE equals, we already know that this is a base 64 number, right? So if I just copy this and I go back to CyberChef, and instead of making it to base 64, because I already have the base 64 encoded version, I'm going to put a new recipe called from base 64.
How did you do that? What do you mean? From 64. Oh, drag and drop. I did not know. That's how it works. Okay.
And now I'm going to copy it here, and I already know this kid's ID is number 11. It's just being encoded with base 64.
Okay.
So what I want to do is I want to ask for the application to give me the kid that has the birth date, specifically, I think it was, yes, 17 of April of 2019. In order for me to get that answer, I need to make a lot of requests with different IDs until I get the right answer. So how are we going to do that? I made things a little bit easier for us. So I have a payload that I'm going to share with you. So basically, I have this list right here. This is basically numbers between 10 and 20, okay? And we can use this as our payload. Before we do that, we need to define this as our input field. This is the value that we are going to change every single request. The way you do that is you basically highlight it and you click on this little button on the left, add. Boom, there we go. Now, if you notice on the right side, we now have the option to configure our payload, which is exactly what we are going to do in just a second. So minimize all of it, right? Let's just minimize everything and let's open our terminal. Terminal is right here on the top left. Just click on it. It will open. And I'll just type the word Pluma. Pluma is just a text editor within Linux. So it's very, very simple. You could also do this on the command line. I know, chill out. Let's try to keep it beginner friendly. And I think this is also better because it allows you to see what is happening. So I'm just going to copy my list here. Remember, this is encoded numbers. This is numbers between 10 and 20. I'm going to save this on my desktop as basically just a text file. I'm going to call it list1.txt and save. And now you can see it here on the screen on the bottom left. I'm going to just leave this here. I'm going back to burp. And right now here on the right side for the payload configuration, I can load my payload. Basically,
which one do you use?
To just leave this here, I'm going back to burp. And right now, here on the right side for the payload configuration, I can load my payload. Basically, I'm going to click there on the load option, going to the desktop, select my list one, which is the text file that we just created. And now we're ready to run the attack. So let's just do that. We're just going to click on this orange button that says start attack. Boom. Let's see how it goes. Just clicking here, okay? The thing got minimized. Don't worry. Just go back to it, to the intruder window. Okay, so we have a lot of information here. So everything returned with a status code of 200, which is good. This code means that the web server actually responded with the information that we were asking for, and we have access to it and everything is all right, even though we are trying to access information that we should have access to, but still, it means that the request worked. And now, if I just pull this little window here from the bottom, we can see the specific web request. The first thing that we requested was the MTE, which was the original request. And now let's just navigate through all of the options, through all of the requests we did, trying to find the birth date that we are trying to get. So for that, we need to click on the response, because this is...
How did he open in the intruder? Is my thing stuck? Ugh, I think I'm crashing. No, my stuff is on the right here.
Where you will see the field for the birth rate here on the bottom. So the first one obviously is not the right one. So let's just keep navigating. So I'm going to go, so 1, 2, I'm just clicking on the down arrow to see if we can find it. I know it's 17th of April 2019, and there we go. So number 10, this guy, first name Willow, is the guy that has the birth date that we were looking for, and we can see that the child ID is number 19. If we go back to the request, child ID is this base64 encoded string, but here it just comes decoded with the basic 19. So if we go back to our main page and we check for the answer for this here on the orange light bulb, we can see that the right answer is 19. So we got it right. Perfect. So I'm just going to click check on that. Now for the last one, please bear with me for a second, because this one is not as easy as the previous one, because it requires you to do some math and to understand how the tokens are built and to really understand this part right here. So you remember this text we read? Yes. This is important for the last question, but let's just read through it and take a look. So bonus task, want to go even further? Using the parents vouchers claim endpoint, find a voucher that is valid on, take a look at this, pay attention, specifically on November 20th, 2025. And we also have insider information that tells us that the voucher was generated exactly on the minute, so every single minute between 20 and 24 UTC that day. So that every single minute there is a possibility that the voucher was generated. So between 8 p.m. and midnight, or 20 and 24, that's 4 hours, right? And because we know that the voucher was generated exactly on the minute, well, every hour has 60 minutes. And if we are talking about a 4 hours gap between these two timestamps, well, 4 times 60, that's 240. So we have 240 options to make this voucher. And now, how do we do that? I made things easier for you. This is a very, very good example of how you can leverage AI to help you as well to generate all of these possibilities, because as we saw previously, the fact that we are using this version 1 of UUID means that even though this token or this voucher looks kind of random, if we know exactly the timestamp or the possibilities for the timestamp of the voucher, we can generate a bunch of different vouchers and then test to see if any of those is valid. So because we have that, you can query AI and ask for a voucher, and you can even give an example of the vouchers that we have on our main app. So one of the vouchers that we have here, and then say, hey, I know there's one valid voucher that was created between 20 and 24 of this specific day, and I need to test which one of those was valid. And the voucher was generated exactly on a specific minute. So we already did the math there. There's 240 options, and I already have the list ready for you guys. So I have the list right here. So if I just scroll down and I copy this, this was the list of potential vouchers that I generated. Right now, what we need to do is we first need to go back to the endpoint that TryHackMe is asking us to use. So let me just copy this right here. Boom. Let me navigate to it. So here. There we go. All right. We're in the right spot. So now we need to go here and claim voucher. Let's just click here on this claim voucher. And here you can enter anything you want, okay? Let's just put test. I'm even gonna make it caps lock just to make it a little bit more visible when we get it on burp. And we can see that we get a result voucher not found. So if I go back to burp, and let me close this intruder window. We don't really need it anymore. You can discard it. And we go back to our proxy. And we go into this last request we made. It's a post request, not a get request, because now we are sending input to the web server. We are not just asking for information. So now you will see that here on the bottom, the voucher that I tried to redeem was test. And what was the response here on the right? Voucher not found, error 404. So now we are going to use the same request. Again, this is the same exact logic from the previous question we got. So let's just send this request to intruder, navigate to intruder. And now, like we did before with the kid user ID, we are going to use the input for the vouchers. So this test string that I included, I'm going to select it as my input field, and you just do that by, again, selecting it and clicking on this add button on the left. And now on the right side, you already have the options to submit your payload, which is what we are going to do. So let me go back to my list, copy it. This is the list that I have generated. We go back to the attack machine, minimize everything. Remember the Pluma text editor? You can just double click here on this bar or file and new. I'm just going to double click here. You paste all of the possible vouchers and you can see there's 240. I'm going to save this as list2.txt and save it on the desktop as well, just because it's easier. Now everything is right here. You can see list 1 and list 2 here at the bottom of my screen. Can minimize it. And now go back to burp, load that payload that we got, open it, and now let's start the attack. Now this is probably going to take a little bit longer because, again, we're not just testing 10 or 20 different possibilities. We are testing, as you can see here on the right, payload count 240 different possibilities. So I'm just going to run the attack. Click OK. And again, because most of these vouchers will be invalid or not legit, you will get 404 not found status codes. What we are looking for is a status code of 200, which means that we were successful and that voucher is actually valid. So let's see if we can find it. This is still running though. It's 240 possibilities, so it's still, you can see here on the bottom left, 36, 37. It's double click on it and make it red so it's more visible. And right now, okay, let me pull up this window here from the bottom, because I know this had a 200 status code. I know it was successful, so I already know this is the one. Maybe there's a couple more, I don't know. The question was just talking about one voucher. So maybe there's a couple more in there, but I'm just going to go with this one for now. So there is this request that we did. We provided this voucher. If we go here to the red, it's the one that is right here on the payload. And let me check the response. Boom. It's okay, as you can see here on the top. So this was the voucher that actually was legit. So I can see that it starts with 22643E00 C655, and I think all of the rest is basically the same for all of the payloads, if I can check it right here. Exactly. So the later part is basically the same, but this part in the beginning, these first two set of characters are the ones that are variable. So if this matches our right answer, we got it. So let me just check it. Bonus question. Let me check here on the hint on the right side. Answer 22643E00C655, and yes, we got it. Awesome. So let's just check it. If you enjoyed today's room, check our complete IDOR room. Make sure you do that, because as you could see, this is a lot of fun. And I'm just going to check that, and we're done.
Cool. That was pretty informative. Very interesting stuff. Okay. I will be done with IDOR, and we'll be moving on to the next section probably tomorrow.